Ways to represent relations. Remember we said relations are when you just pair numbers together. So we're going to look at ordered pairs, table, mappings, equations, or graphs. Let's start with ordered pairs. I would argue this is the easiest one. What do you think? Yeah. When they're listed as an ordered pair? You should already know how to do this. This is nothing new. So please take off with it. Tune me out if you already know how to do it. If you're struggling or don't remember, then lean in as I walk through it. So here we've got a set notation. This is a good review. Let's remind yourself that this is set notation. When you got the squiggly, remember we said squiggly starts with an S and set starts with an S. So when you got a squiggly, it's a set notation. Domain means look at which part? Give me, you are correct, but give me a specific coordinate. X. Domain means look at the X coordinate. And range means, Brandon, look at the Y coordinate. Very good. So you're going to list the domain and the range here in a set. So draw your squiggly. And then list the domain and the range. You just separate the numbers by commas. There is one nitpicky detail. You need to put it in order. Needs to be in increasing order. That is a nitpicky detail. So this should almost be muscle memory. Please quit with the little side chatter. So here, did you write -102? Kind of hard to see when you're looking at it horizontally. So I like to draw arrows to the X's so that I don't mess up. And then what's my range? Hampton, what are my range values? Nice. I'll stop. I'm not going to listen to that crap. All right. Is it a function or not? Well, I don't really have a graph here, so I can't run my vertical line test. But remember we said a functioning vending machine. What am I looking for? Well, I'm looking for my, what'd you say? Inputs, and I'm making sure that they don't repeat, right? My inputs, because that would be like pushing that button on the vending machine multiple times. And a functioning vending machine, I should be able to just push the button one time, and then I get an answer, right? So I should only see -1 once. I should only see 0 once. I should only see 2 once. Does that make sense? So is this a function? Yes. Now, please repeat the process you just did, but move to tables. You should find it just as simple, if not easier, because they're listed side by side instead of horizontally. I need to write the second 3?
No.
No. And because you just repeated an input, that would be like walking up to a vending machine and pushing 3, where a 1 comes out and then a 6 comes out. That's not a functioning vending machine. So we can go ahead and answer, is this a function? No. And the problem is, if you want to make a note, like, this is what you've got to practice doing. You've got to practice being able to support your answer. One of the problem-solving skills that I'm trying to teach you is, when you have an answer, can you support it? Can you argue it? Think of being a lawyer, which is why I liked math. I used to want to be a lawyer. But then, I'll tell you that story another day. But anyways, I like math because I like arguing. No, I know the answer. Here's why. That 3 has been repeated. It's like if I went to a functioning vending machine and I pushed 3 and it spit out a 1 and a 6, that's not a functioning vending machine, right? So we could say no because 3 is repeated. Range, -4, 1, 2, 6. Is that what you got? My squigglies are struggling right now. Looks like a string on a balloon or something that's flying away. Mappings. Mappings are where the arrows are assigning the X to the Y. Take a second, answer the domain and the range, and then if it's a function, you're looking at mappings. What's the domain? So in a mapping, what's nice about it is that the X coordinates and the Y coordinates are already in descending order. So really the only thing you have to think about is the arrows part. Range, 1, 2. Is it a function, yes or no?
Yes.
It is a function. I have a challenge question for you. Please look up here at the mappings and answer this question. Not out loud. Let everybody have a chance to answer it in their head. In your head, answer this question. Why is 2 in the range allowed to be repeated? Don't answer out loud. Why is 2 in the range? You said it is a function. You're correct. Why is the 2 allowed to be repeated? Now, I would love for someone to raise their hand and tell me why. We're going to make sure everybody's getting to participate. No, I've not heard you in a while. There you go. That's it. Did you have a different way to describe it, Logan? Was it the same description? Different way to describe it? No? Different way to describe it? What were you going to say?
The 2 numbers equal the same output.
Because it's in the outputs? Because it's in the outputs part? Yeah. So that's another way to describe what he said. He said because it's in the Y. He said because it's an output, and they're both correct, okay? So the 2 outputs can be repeated. The problem is inputs cannot. All right. Let's move over here to graphs. To graphs, please. You're going to write the domain and the range. This would be that challenging question. Remember, we practiced visualizing highlighted sections popping up. So you're going to visualize that highlighted section. Think back to that Desmos where you got to slide the sliders to make it match. visualize a highlighted section popping up to represent the domain. Then turn your head sideways and visualize a highlighted section popping up to represent the range. I want everybody to try it first. Just try it. So if you're struggling with this, you are asking yourself, where would I drop some highlighted sections to cover the graph? Okay. So for instance, looking right here, how many sections of the graph is there? Here. There's 3. How many shaded sections then will I have? 3. What does a closed circle mean? Equal to? What's an open circle mean? Yeah, or you could just say not equal to, right? So I'm going to drag this because it's a solid line. I'm going to drag this to cover this shaded section. Watch what I'm doing, y'all. Am I covering the graph yet? That first graph, am I covering it?
No. Or yes.
But am I covering too much?
Yes.
Please look up here. What about now? Should I keep? You need to think of a vertical highlighted section covering the graph. Is this one finished? Okay, now we're going to fix this one. This one's going to go to a closed circle. Tell me when to stop. Stop. Okay, now I've got to drag this part. This is going to go to the open circle. Tell me when to stop. What did I do? I went too far. I was hoping y'all would say that. What about now? Not quite. What about now? I think I'm on it now, aren't I? All right. All right, now we're going to drag this. Where should I go? Should I stop here? 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 All the way? All right, what about this? I'm too far. I'm not covering the whole graph. Whoops. So, like right here? Then you would go to the x-axis and you would read the numbers, like the low bound and high bound. So, like the numbers here. I don't think this is going to look right. Oh, yay! So the numbers here. Watch how I do this. This is the origin right here. So this is -1, count with me, -2, -3, what's this? Oh, is it counting by 2? It's counting by 2s, look, because that's -10. So hold on. Counting by 2, so this is 0, -2, -4, -6, what's this? -8. Are y'all listening? I know some of you are.
I just got shot in my face.
Can you wait a minute? So this is -8. This is kind of hard to see. We're going to say this was -2. So this is probably -3. I'll help you on that one. It's kind of hard. It's in the middle. All right. So this shaded section would be bracket -8 to -3 bracket. And that's because it's solid. It's running, the graph is running -3 to -8 to -3. Then we would have to do a union to say, okay, let's connect it to the next shaded section. This would be -2 to, this is 2, this is 4. So it would be -2 to 4. That -2 is actually an open circle, so it would be a parentheses.
I thought that 4 was something too.
Then to read the next one, this is 5, and this is infinity. So the last one we would say union with parenthesis on 5 to infinity and beyond. So that's the domain for that picture. I'm asking you to tell me the domain for yours, which should be easier because there's just one picture. There's not 3 parts. To read the range, it's the same concept as this, but you turn your head sideways and you imagine the highlighted bars being moved like down or up, okay? All right, so let's see how well you did. You can go, what is it? So the nice thing about having the board up here is I can actually draw the highlighted section and then just quickly erase it. So watch how I do this with a highlighter. So I'm going to picture a highlighted section dropping straight up and down, right? So it's the graph over here. No, not at all. It's the graph here. Look careful. Have I hit the graph? Yes. No. I need to start it where I hit the graph. So it would be like here, right? And it would continue to there. So I'm going to read those x values on the x-axis. This is what?
Negative 4.
Negative, wait a minute, it's hard to see. So this is the origin here. So negative 1, 2, 3, negative 4, right? And then this, if this is the origin, this would be positive 1. So your domain is running from negative 4 to 1. Negative 4 to 1. Put brackets because it's definitely touching those points. There's no open circle here. Now turn your head sideways or turn your highlighter sideways, and now you're going to shade low bound to high bound. So it's the graph here. Nope. What about here? Nope. My low bound starts around here and it goes to there. Now you're going to read those points on the y-axis. So this, I got to remind myself, this is the origin. So this is it negative 2? And then 1, 2 to 3? Positive, right? Because you're going up on the y-axis. No, that's the x value. Be careful. Your y is up and down. So positive is up and negative is down always. So our range is going to be negative 2 to 3. Question, is it a function?
No.
Definitely not. What would be your argument?
It fails the vertical line.
There you go. Because tails, I'm going to just write vertical T line test. All right, last one's going to require your graphing calculator. Go to your graphing calculator. We're also going to be using the Desmos graphing calculator from time to time. Right now, we're just going to use ours. You're going to go to your graphing calculator, and we're going to graph this. You will notice that this equation is already in what's called y equals mode. It's already in y equals mode. That means you can type this in your graphing calculator. If it were not y equals mode, then you would have to use Desmos, okay? How do we type it in? So we're going to do this. We're going to push the y equals button, top left. If there's anything in there, just hit clear. Make sure yours does read Y1, Y2, Y3, because my college students were using the calculators for polar equations. Make sure it says Y1, yes, Y2. Okay. Now we're going to type the equation. The equation was x squared minus 1. So, x, here's the x variable button, right here. Whoops, I did too many. It's right next to alpha. Now, to get the squared, there's a squared shortcut button. It's on the left. It actually says x squared. And then to do minus, remember there's a difference between minus and negative. This is the minus button above the plus button.
How do you get the X?
This button right here. Next to alpha.
I'm gonna click the alpha button.
It's giving you T. It's in parametric form. Yeah. That's because yours is it's a different form. See, it doesn't say Y1. That's okay. You're in parametric form. You're out now. Now, after you type it in, now what we're going to do is we're going to do the good old-fashioned Zoom 6. Zoom 6 means just give me a standard viewing window, negative 10 to 10, negative 10 to 10. That's your standard viewing window. Then you can adjust from there. How do you get Zoom 6? Here we go. There's a Zoom button. Zoom. It's going to say, all right, how do you want to zoom? There's different ways to zoom. We just want to do the standard viewing window, which is 6. Standard viewing window. So you're going to punch 6.
Oh my God! I didn't press it.
Now you have your graph. Now what we're going to do is we're going to sketch this on our paper and we're going to write the domain and the range. Sketch it on your paper, write the domain and the range. You can see that this is bottoming out at what number?
No.
Bottoming out at negative 1. You can see it's crossing the x-axis at negative 1 and positive 1, but then it's going up and out, right? Alright, so let's sketch a picture as best as we can. Right here, we've got negative 1, and I'm just going to draw a U that way, and a U, ooh, that was ugly. I'm going to draw one that way. And I'm going to call this negative 1, and this is 1. So we have our graph. Now we're going to read the domain and the range. The domain is all the x values covered. What do you notice it's going to cover? Domain is the x values. Imagine me coming in with a highlighter and shading the parts of the graph that it's covering. What would I end up shading? As it's going up, it's also going out. So what would I end up shading? What infinity? The whole thing? What are you getting at?
I would say shade through the X-axis.
I am going to shade through the x-axis. How much of it?
Like from.
So remember, as it's going out, as it's going up, it's also going out, which implies, Tori, say it again, infinities. Which ones?
Positive and negative.
Both. Alright, so it's going to cover the whole thing. Can't see that right here. We can't possibly graph it. But as this is going up, it's also coming left. As this is going up, it's also going right. So to the left is negative infinity. To the right is positive infinity. The correct way to answer this question is to say all real numbers. But the way to write that in interval notation is negative infinity to positive infinity. So negative infinity to positive infinity. Quit talking. I want you to make a note that that stands for all real numbers, which means every single number on the number line. Now, range. Imagine a highlighter running across is the graph down here. Look where I highlighted. Is the graph down there? No? What about here?
No.
No? Where does it start?
At the very bottom.
What's the lowest? Negative
Negative
1.
1.
And which way does it go?
Left to right.
To
Up.
infinity.
And
So
beyond.
take a second and write the interval for range. Definitely has a bottom value of negative 1 and it's going to infinity. It is closed. And that's because they didn't give us an open circle there. Is this a function?
Yes.
Yes. Okay, put that paper away. Switch over to key characteristics of functions. That was a nice little summary to help you understand. Hey,